Alright, now let's turn our attention to the heart of pretty much every processing application, the draw method. In this method, we're going to have to draw the face of the clock, the numbers on the clock, and then three hands: second hand, minute hand, and hour hand. Okay, so in our draw method, the first thing we'll do, since we have an animated display window, is we'll erase the background at the beginning of the draw method, and then we'll proceed to do the rest of our pieces. So we're going to go ahead and draw the face of the clock, and we're going to do that with a 1 pixel weight line, and that will be just an ellipse call to make that happen. And so we'll start our ellipse in the center of the display window and make its diameter, the face diameter, constant. And now at this point we have the face drawn. Okay? Then we'll go ahead and do our three hands: our second hand, minute hand, and hour hand. Okay? The second hand will still be drawn with a stroke weight of 1, so we don't need to change that. What we do need, though, is to determine the theta angle, and then use the correct radial length for our polar coordinates. Okay? So here's the idea. There's 2 pi radians all the way around our clock face. And what we're going to multiply that by is the fraction of the number of seconds that we've had divided by 60. Okay? So in other words, whatever our current second value is, we'll divide by 60, and that will give us a scaled value of theta between 0 and 2 pi according to the current second value. Okay? Now we're going to go ahead and call our convert and translate method, because we know the radians and the distance, the r value. So we're going to go ahead and send in that angle and our distance, or length of the second hand. And now we know where the end of the second hand is. So the next piece, very simple. We're just going to draw a line from the center of the app's display window to the end of the second hand, and we can do that in this vector by specifying the object name and then .x and .y for the coordinates. Okay, so that should do our second hand. Now our minute hand is going to be very similar. Okay, we'll make it a little bit heavier line, so 2 pixel width, and then our angle is going to be very similar as well. It'll be 2 pi times the minute value divided by 60. Okay, and then we'll just do a little bit of a copy and paste here, because we're still going to call our convert and translate method, except now we'll use the minute hand length, and then our line method call is actually just the same. We're just providing different values for it. Okay? And the hour hand, we'll make it a little bit thicker, so it's going to be a 4 pixel weight line. But our math is a little bit harder because we want the hour hand to sweep more smoothly through the face of the clock. In other words, we don't want it to jump from 4 to 5 and not be anywhere in between, say at 4:30. Okay? So we still have our 2 pi value, because that's 1 trip around the unit circle. Okay? But now we're going to take our hour value, first of all, and get rid of its military time aspect by doing the mod 12 that we talked about before. Oops. Then to that value, we're going to add a fraction, which is that minute divided by 60. Okay? So that will have it move between, let's say again, 4 and 5 as the time progresses from 4 to 5, smoothly instead of jumping in one large piece. And then overall now that's going to be a number between 1 and 12, or 0 and 11 point whatever, 999. So we'll divide that by 12.0 to give our fraction between 0 and 1 that we multiply by 2 pi to get our hour hand position. Okay? Then our endpoint, again, will be very similar to what we had before. Now that we've done the math for theta, we'll just pass in the hour hand length at this point. And our line method call is exactly the same as it was before. Okay. And the last piece we have is our text. So we're going to go ahead and draw the numbers 1 through 12. Okay. And so we'll do a similar thing with our angles. So it'll be 2 pi times our number divided by 12.0. And just to be persnickety, doesn't really matter, but we'll do that to make sure that our intention is known. Okay? And our endpoint, again, a convert and translate method call. And we'll use a second hand length as our positioning, or our distance rather, for the numbers from the center. And now to actually do the text drawing, we'll call the text method. The text method needs a string, so we'll call the integer toString method on number. That'll be the string that we're going to draw. And now endpoint.x, endpoint.y. There we go, and that's the end of our draw method. Now if we've done everything right and we run the app, we should see our analog clock. Let's see what happens. And there we go. Here's our analog clock ticking away as it should. So we should see the minute hand advance by 1 minute once we get up to the 12. The hour hand will move just a little bit closer to 9 as we progress. And we'll see if that actually happens. Tick, 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 tick. There we go. And so our clock says 8:51, which is what it should. All right, very good. That's how we code up our analog clock. So we're going to go ahead and wrap things up. We'll talk about what we might want to add and what kind of improvements you might be able to make to this next. Okay, let's wrap things up here by talking about what you might add to this code, things you might do to make it different. And you'll certainly think of other things if you watch this and look at the code that you might do differently or you might change. And hey, go for it. Have fun with it. Here's some ideas I had. First of all, make it pretty. Obviously, it's not a very exciting looking application, just black and white, simple lines, kind of minimalistic. So you could certainly do some work to make it more interesting visually. And that would be something that would be interesting. Also, the second hand right now has got that tick, tick, tick action going on where it ticks once per second. We could make it into sort of a different kind of analog clock and have the second hand sweep smoothly rather than tick. And you might be able to do that by adding on a fraction derived from the milliseconds value of the system clock, let's say. Also, you could do the same with the minute hand and the hour hand. If you notice that the minute hand and hour hand move up by a 1 minute or 1/60th of an hour quanta each time, and if you wanted to make it pure analog with a smooth second hand, you might also have the minute hand and the hour hand move more smoothly, which again would probably involve adding more fractional components into the multiplier of the 2 pi radians value, and so on and so forth. Have fun with it. Anyway, this is just the basis of an analog clock, and yeah, hope it was fun for you. If you'd like to see the source code and see some other content, you can go to our website, programmingandprocessing.com, And keep checking back here to this web channel or YouTube channel for more videos.